Bonjour, je m'appelle Sébastien Florent, je suis le directeur de la gouvernance des données et des partenariats à la Direction générale du responsable des données d'immigration, réfugiés et de la citoyenneté du Canada. Welcome to the Data Literacy Fest. During the next 2 days, you will find a wide range of workshops representing 11 federal government departments. The Data Literacy Fest highlights projects showing a selection of data-centric initiatives and various tools aimed at developing the data literacy skills of public servants. Nous nous réjouissons de votre participation à ces ateliers par le biais de Slido et d'autres formes d'interaction. Allons-y. Si vous voulez vous connecter avec vos pairs, je vous invite à nous rejoindre sur wonder.me. Bonne conférence.
Good morning, all. Thank you for joining us today for a workshop on data engineering challenges and solutions and a demonstration of Shiny. My name is Sarah McCullough, and I'm the lead for data literacy in the Chief Data Office at the Canada Border Services Agency. I'm pleased to introduce Dmitry Gorodnichy, who will be presenting today. Dmitry is a research data scientist in the Data Science Division at the CBO in the CBSA. Dmitry has a PhD in computing science from the University of Alberta and a Master's of Science in Applied Math from the Moscow Institute of Physics and Technology, the focus of both of these being artificial intelligence. Prior to joining the CBO last summer, he worked as a research scientist, starting in 2000 at the National Research Council of Canada, and then joining the CBSA's Science and Engineering Lab in 2008, where he led projects related to the development of biometric and intelligent video surveillance technologies. To get started today, I'd like to invite you to open Slido. The link is in the agenda for the conference, and the code for this event is all caps CBSA1. We'd like to get to know your opinion on data engineering challenges and concepts. And I'll start by reading out those questions and answers. So, how often do you manipulate data? So, practically never. Occasionally, sometimes you use spreadsheets to compute totals and averages. This is a part of your work, but not the main part, and that's your main job. Okay.
So good morning, everyone. It's Dmitry. I'm just checking how many people have already logged into Slido. It seems like more and more people are joining. Now we have 16. So it's the beginning. It's the Monday morning. Surely people are still waking up, some of us, and trying to find Slido. So again, sli.do / and then you would type the code. So, okay, Sarah, to you.
All right, are you seeing results there for the first question?
Now, on my part, I don't see the results, so do you see it?
I don't. So if you're okay, maybe we'll move to the second question there. Okay. So which tasks from the list below have you ever had to do? Start with trying to find a word or phrase in data, the exact spelling of which you don't know. You have to remove or correct accents or transliterate words, remove special symbols and gibberish, correct typos made by yourself or others, expand abbreviations, word contractions, or jargon, or use VLOOKUP or any other tool to merge two or more data sets.
So again, I see that more and more people are joining, Sarah. So that's good news. Perfect. So indeed, I guess it's very hard to expect that everyone is right on time at 9 o'clock on Monday morning. So now we have already 25 people, and I see more and more joining. So again, the first 5 minutes is really for us to get together, to wake up, and to start getting introduced to the topics which we will be discussing today. Because all of these questions are prepared for a reason. So the first question was really about the audience. We're trying to understand where you're coming from, because data area is huge, where there are many practitioners of data, but coming from different sides, right? And for some of us, it's our main job, like for example, for myself. But for most of my colleagues, it is part of their job, but not, of course, the main one. There are many other components. So it's very important for us to know, indeed, what is the percentage of the audience who are actually familiar with the manipulation of data. What does it mean to try to clean the data yourself, and how hard it is to do sometimes. And this is what the second question was about. So these are typical questions or typical tasks which many of us are doing. I'm sure many of us are doing, like trying to find a word or a phrase when it is misspelled, or you don't know how it is spelled. For example, my name is spelled with the Y, but many people spell it with I, and you won't be able to find it with the Control F. So how would you do it? And this is a very typical data search task. And similar with other questions. Oh, by the way, again, we now have 38 people. So indeed, I'll use this time to get us introduced to the challenges of data engineering. So in our second question, we are asking which of the tasks from the list have you actually encountered yourself? And of course, many of us have dealt with accents, right? Sometimes they're written, sometimes they are not. And of course, these words will not be matched if they are spelled differently. And of course, sometimes we have special symbols. Sometimes we have data pasted from the web and has some hashtags or any other symbols. And of just typical typos. How many typos do we do and or our colleagues do when we just write, right? So all of these need to be eventually cleaned or merged at some point. And of course, abbreviations, like all these many abbreviations which we use without even thinking about them, but they also need to be linked with the actual names. And some of us, yes, we use spreadsheets, and in spreadsheets there is a function VLOOKUP which allows you to link to data sets. But again, provided that they match exactly, at least portions of them. So third question, Sarah.
All right. So, what do you think GIGO, garbage in, garbage out, LTE, IoT, Internet of Things, and bias in AI have in common? Are these buzzwords of our time? They're just all abbreviations, all have data in their origin, or they're solutions in data engineering? Dmitry, would you like me to go through the rest of the questions, and then we can see all of the responses, and then your presentation?
I see that, again, we can just use this time to réchauffer, pour se réchauffer, comme on dit en français, so to get into the tune. And again, because more and more people are joining pretty much, I see, every 15 seconds. So what do we see in this question? Actually, we see one of the key challenges of data engineering, which is dealing with abbreviations. Because, again, abbreviations will need to be matched to the actual definition of those terms when you have two different data sets. And of course, all those concepts, in fact, we've heard many of them even at this conference. Garbage in, garbage out. If you don't clean the data, you will get garbage results. You know, this is very well known. Now, load, transfer, extract. One of the first talks in our first plenary on Thursday, André Loranger from Stats Canada was talking and emphasizing the importance of cleaning and loading the data, and actually he even mentioned that it takes 90% of our time. I thought it's 80%, but actually he said it's 90% of most of our time, which we do in data analysis, goes into loading, cleaning data. So imagine how much work is spent just trying to merge these different pieces of data. Then Internet of Things, it's huge, it's ever-growing, exponentially growing amount of information, which we'd like, of course, to use. And if we don't build the systems which can do it automatically extract data, meaningful data from this huge cloud universe, we call it universe of data, because it's all these concepts have in common data. And of course, bias. many people right now talk about the importance of confidence in decisions. We should make sure that there is no embedded bias in solutions. And what is bias? Bias means that the data was not perhaps properly cleaned. If you removed all words which have accents, you immediately remove French-speaking population, for example. And I've encountered myself. So bias, in many cases, it's unconscious bias. It could be not intentional, but it is bias. And unfortunately, if we don't deal with the cleaning of data properly, we will introduce this unintentional bias in many, many systems. So this is how important data engineering is. So in fact, all four answers are correct. But again, we're just trying to see what you think about it. Okay, Sarah, yours.
Okay, so the next question is, what is for you the best description of data engineering? Is it the primary need in the pyramid of all data analysis needs, a subfield of data science that deals with automation of data processing and analysis, data programming integrated over time, software engineering applied to data science problems, all tools and processes that organizations use to build and maintain data-driven solutions and systems, or the bridge that connects data scientists and the rest of us with the universe of data?
And as you answer the questions, you would see that all of these are the various definitions of data engineering. In fact, when I was preparing for this workshop, I was looking for the formal definition of data engineering anywhere, and I couldn't find it anywhere, but there were many blogs which were dedicated to data engineering, to the subject of data engineering. So all of these were taken from different blogs. And again, don't be shy to check all of them or just one of them. But essentially, these are different descriptions of what data engineering is according to some professionals who are working in the field of data engineering. So we already talked about the data engineering as being at the bottom of the pyramid of needs for all other data analysis tasks, which takes 90 or 80% of our efforts. Now, we also know that it's a part of data science, which specifically deals with automation of data processing, because if you have unlimited data, you cannot do it manually. It has to be automated. Similarly with data programming over time, you build a solution today, it must be future-proof. The concept of future-proofing is very much related to programming. So it needs to, your solution which you build today needs to be capable to work with the data tomorrow, and it needs to be developed in such a way that you can build on top of it, so you can improve it over time, and you can build what is called scalable solutions, which again can deal with any amount of data. And then we go to the definition of data science as a software engineering, essentially, which is applied to data science problem. And software engineering, as opposed to data engineering, which is probably less than 5 years old, but software engineering is more than 50 years old. There are transactions of proceedings and conferences which talk about how to develop the code in a robust manner, in a modular manner. So it all has to do also with data engineering, of course. And eventually, data engineering is not only the codes which we write, but it's also the processes which we use to maintain the code, to maintain the knowledge which we gain today so that we can use it tomorrow. And I like myself the final one, which is it's actually the bridge which connects data scientists with this universe of data. Okay, the next question, Sarah.
Sure. Now, what is R for you? Is it the inverted spherical letter R transliterated as ya or ya in English? Is it the COVID-19 growth rate, aka reproduction rate, one-dimensional real numbers, or the fastest growing in popularity and community support programming language for data analysis and visualization?
So here we come to the main topic of our presentation today, where we'll be talking about the programming environment or language called R. And this language has grown in popularity with the historically fast. It was ranked 18 2 years ago, now it's ranked in one site ranked number 5, and some other ranked number 8. So indeed, it has become probably the most popular language for data analysis and visualization specifically.
So all answers are correct.
Exactly. Now, it also shows the problem which we deal with data engineering, that when you have words from different languages, like from Cyrillic, like my name is Dmitry, for example, or for example, names like Tanya, Sonia, they will be spelled differently when transliterated in English or French. And of course, COVID provides lots of data. We have data for Canada, which we can now merge with postal code, with census data, and any other data. That's what we'd like to do. Okay, next question.
Sure. What is shiny for you? Is it a beach in Florida, translation of brilliant into English, a Boney M song, or an R package to build interactive interfaces for analyzing and visualizing data? So I think for the purposes of this presentation, there is an answer, but they're all still correct.
Yeah, and here I will just say that R package called Shiny, in fact, this is one of the advantages of R, let's say, over Python, another language which is very popular for data science, that it has this package Shiny, which allows you to interactively analyze the data. And this is very important because you need to make sure that when you change the input slightly, you introduce a space or accent, and it does not ruin your code. So this is what we are developing. We're developing the essentially application, interactive web application, the link to which you will be given. And you will just play with data yourself. You can introduce noise as much as possible, and you see how whether the output is affected or not. So interaction is very important for testing. And this is what Shiny allows us to do. Okay? And the last one.
So the last question is, we'd like to know what you want to get out of this workshop. Are you hoping to get tools that will help you to do your data work, knowledge that will help you to develop tools for yourself, to connect with colleagues, or are you looking for entertainment?
So, and here I can see that we now have 82 people who are participating. This is very good. So let's wait until we get all the answers, and after that we can switch into the PowerPoint presentation.
So just make sure after you answer all of the questions, you hit submit so that we're able to see the responses. I also see some questions coming in, Dmitry. So I guess we can just say that after your presentation, we can address those questions that folks have.
That's correct, yes. And I believe also, so Sarah, I guess you will be, or moderator will be probably using the chat, right? So I'll be looking at the chat window. Is there any questions?
For sure. And actually, Dmitry, if you can just let Hani share the screen, we can see the responses for the Slido questionnaire.
Okay. Let me do it. Okay. So can you see the responses now?
Thanks, Hani. So it looks like most people are looking for tools that will help them do their work with data. So that's perfect.
Very good, very good.
Okay, so I guess, Dmitry, then if you can share again, and we can jump into your presentation.
Just perhaps we go there. Hani, can you show maybe the previous answer? I'm not sure whether it's possible for you to show the answers to the previous questions. Yeah, just to get the idea essentially about the audience. So audience, again, this is very good. So indeed, we see that majority of people who are participating, they in fact are very familiar with data manipulation tasks, but still there are many people who are, for whom, okay, that's very good. So we have a variety of interests, and that's all very good, because I have structured the presentation in such a way that it should be useful, hopefully, for all four types of audience here: those for whom it's the main job, and even those for whom actually they never manipulate the data yourself. Okay, can we check the next question, Hani? Which tasks are most useful? This is very nice. I really love it. So it looks like everyone has done many of those tasks. Awesome. Let's go to the next one. Yeah, so indeed, everyone understands all of this has to do with data. Okay, let's have a look at the next one. And it seems like, in fact, many people see that, of course, it's not only the codes, it's the entire infrastructure, it's the entire set of processes to maintain the code over time, which are very important for data engineering. That's all very good. So we can go to the next one. Yeah, so, and here it's quite clear. Okay, I think we're ready. I think we're ready to jump into the PowerPoint presentation. So I will start sharing my screen. Okay, can you see my screen, Sarah?
I can, yes.
So again, just please let me know if there's any issue with the screen. But again, welcome everyone. A good Monday morning. Dmitry Gorodnichy is my name, and I am the research data scientist with the data science division of Chief Data Office. What is good to say here that actually this division is less than 1 year old, so we're very new and fresh here, and even our directorate, Chief Data Office Directorate, is less than 2 years. So we're very young team here, but as you would see, we're very enthusiastic about what we do, and many results have been already obtained, and we would like to share with them, and we would also like to engage you. We'd like to be working with you together, with you on building solution for all of us, for all government of Canada. So that's what we will be discussing today. First, where the problem comes from, and just a few examples. And we've seen already a few examples in our slide of poll. And of course, we'll talk about how to develop solutions for those problems. So let's see where the problems come from. Of course, it's very easy when data is spelled the same way. It's much harder when it's not spelled the same way. How many ways you can write the date? Can you imagine it? Many days. For humans, it's not a problem. You can see it's the same date. For computers, you need to write a code which would automatically extract just 3 numbers: year, month, and date. And that's what we're building. We're building a function here which will automatically take any data and extract any text, and extract just 3 numbers. So we have provided you the link, and by the way, just I'll quickly again show that you can go now to this link. It's a link to our Shiny app, which we have developed to demonstrate the challenges of data engineering and the solutions which we are building. So you are welcome to go to this website now, but again, just don't upload your data sets yet. But you can go, you can click around, you can explore, and as I go along with the presentation, I will be referring to this website, because now we have a function which is called text to data, and it takes any text you can write any way you want, and it just will extract 3 numbers. The other name, so my name is spelled in so many different ways, and I'm used to that. So again, this is the same person, myself, and ideally computer should be smart enough to understand that this is the same person. And even my name actually had even more variations, because it was spelled in Russian and in Ukrainian slightly different way. So that's why I have sometimes even starting with H. And again, it will be very difficult to merge those 2 data sets, where in one It's G Gorodnichy, and the other one is Gorodnichy with H. And business names and geographic names. So we use abbreviations sometimes. We use sometimes full description. So we need to merge all of this. When data is different, it's very difficult to integrate it. So good to connect the data, we need to link it. And the technique is called fuzzy matching, approximate matching, or probabilistic matching. So, and it allows us to link this noisy, we call it noisy data, but in fact, it's not noisy. It's just the data the way it is in the universe of data. But for a computer, yes, it is noise, and we're helping to link it together so that all words are compared to each other, and then technique called string comparison or string matrix. So here I would like to just to describe how this probabilistic matching works. So let's say you have different spellings of Dmitry in different data sets. So you need to introduce the concept of distance between the words. And the distance, there are many different ways to define the differences. For example, you just can count how many letters are different. For example, Dmitry with I and Y is different only in one character. Okay, you say distance is 1. Okay, so this is called edit matrix. How many edits do you need to do in order to convert one word to another word? How many those edit operations? This is called edit matrix. So then we can use lookup table. So for example, for YOW, it's abbreviation for Ottawa International Airport. Yes, here you will need another lookup table where you will extract the meaning of the abbreviation. Now, a very important concept is Q-gram. It's like kilogram, but actually it's Q-gram. Q stands for the number of characters in a subword. For example, 3 gram means a subword of 3 characters. So in Dmitry you have DMI. It's 3 gram, and then you have MIT. So, and you have a number of those different grams. And then you can count how many of those grams, 3 grams, match in 2 different data sets. Then there is a concept of a phonetic. So why not to just transcribe a word the way it is pronounced, not the way it is spelled? Dmitry, and then it doesn't matter how you spell it. It actually will be always matched. So all these techniques have been developed, in fact, many years ago, even before data science, the term of data science was created, more than 10, 15 years ago. All those concepts have been already introduced and used. And of course, there are many heuristics, for example, which penalize the difference in the first character much more than the difference at the end of the word, because it was found that normally people really put a lot of attention in the first character, and they do many mistakes at the end, and it's okay. So there is a solution, but there are also challenges with this solution, because as you would see, when you compare and you get a metric, and normally, by the way, a metric is also converted into a number between 0 and 1. So 1 means it's very, very different. It's entirely different. 0 means it's entirely correct. So it's exact match. So 0 distance means exact match. But where would you put a threshold if it tells you, okay, the difference between bell and shell is only, let's say, 2. Is it too much or is it not too much? So you would see that you don't know how to, first, you don't know which metric to use. Secondly, you don't know how to assign a threshold. Secondly, thirdly, you don't know how to measure the quality. Because what could happen that you could lose some nuances, like Bell Canada may be matched to Shell Canada. That's a good example from our real life. So no perfect solution. But what we say, the best solution is a human operator combined with intelligence of a machine. It's like we're building AI system, which is fully automated, data engineering built solution, which helps a data analyst interactively with a slider, with the sliders, with some buttons maybe, but it will help a person, a data analyst, to effectively match very complex, very a different data, so that regardless how Ottawa Airport is spelled, it will always be matched to the same YOW. It has been already mentioned that most of the effort of data scientists go into data cleaning engineering issues. So, and what is also very important, there are many of us at CBSA, Canada Border Services Agency, but of course in many other departments, who are working on the same data cleaning challenges. We have many data sets. In fact, Open Canada offers many data sets. By default, all data produced by the Government of Canada is open by default. So it's open, but it means that in order to link it, you should develop techniques to allow this probabilistic matching of different spellings of the same words. So we need to be working together. We need not to be reinventing solutions. In fact, many of those solutions, as mentioned, have been developed 15 years ago. So, and here I would like also to emphasize something. CBSA is a very much operational agency. As our Director General Sandy Kyriakakis said on Friday chat, we have this very clear mandate. We affect Canadians and Canadian businesses every day. Our solutions, our decisions affect every day Canadians and Canadian business. So we cannot afford spending too much time building solutions. And we cannot afford building poor solutions or suboptimal solutions. We need to be able to build solutions fast and to build solutions which are good. And in order to do that, we need to leverage the best, the state-of-the-art solutions which are available, which are provided by this huge community. And it has been emphasized that R is now supported by hundreds of thousands of data scientists and data engineers. So many packages, many codes have been written. We do not need to write those quite complex data linking codes ourselves. Many packages have been written, and I do provide references to some of them which we have tested. And because what could happen that there are many packages, but not all are equally good. So in order to actually to apply it, you do need to do research. And actually, this is why my position is actually part of my mandate is to do this research and quality analysis. So we just cannot take a package and assume it works. We need to benchmark it. We need to, again, to see how it works with different types of data. So we need to do two things. We need to be able to leverage the solutions which are available, and we need to be able to test them. And this is what we're doing here. And we're inviting you to join our efforts to build those data engineering tools collectively. How do we do it? Now, we have a very good tool to do that. It's called GCCode. So, Shared Canada have provided us with what is called source control solution. It's a GitLab in professional that's professional name, but we refer to GCCode. So we put our codes there. We put not just codes, we put all the papers, all the data sets, all the references. So it's available, it's open, it's free for all Government of Canada employees. So we have created a portal there, which is called R4GC. So that's our icon for this portal. Everyone is welcome to go there and to see what we have already built there. It's again, we're using it as a repository because, as mentioned, data engineering is as much about the knowledge as about the actual coding. So we put a lot of effort into curating the knowledge which we're getting specifically for data cleaning. So, that's what we're doing here. Now, here we will be showing you a demonstration of what we have achieved so far. As mentioned, this work has just started since September, so less than half a year. You can go to this link at GCCode and you could see many already code snippets and again frequently asked questions. For example, how do I use source control? How can I contribute? All the answers are there. So very importantly, we use only open source, only public data. It's very important to emphasize. We never use in these demonstrations any CBSA data, any protected data, private data. So we leverage public data and public knowledge, specifically knowledge coming from the experts in R. Who, we have to admit, we are not experts. We are learning. We have opportunity to learn fast if we tap into this growing knowledge of global community. And we can do it. Now we're building a solution for the community, but we are also building the community itself, the community of practice. So we are hoping to build together with the Stats Canada Data Science Network. And by the way, next at the end of March, I will also be giving a presentation at Stats Canada about the same, but we'll talk about maybe how we can work collectively, collaboratively to contribute our codes and solutions. So what do we plan? We plan to develop the actual package by the end of maybe this fiscal year. But before the package is developed, so what the package will be able to do? It will be able to get open Canada data. It will be able to merge different open Canada data. It could be COVID and census, COVID and postal. It could be anything. So, and do just generic tasks. So, but again, we would like not to be building all those codes from the scratch, because there are again many packages. What we're trying to do is to review all those packages, to test them, to select the best ones, know which package is the best for each problem, because again, packages are developed for different problems in mind. So we need to test. And then we can build a toolkit, like end-user toolkit. So which eventually anyone who even is not doing data manipulation themselves, you would be able just to upload your data and it will nicely clean you the data, just the way I will show you in 5 minutes. As we go along, we of course work with our clients. We have many projects going on in CBSA. Again, I will not be talking about those projects here, but you can imagine each of those projects have many data cleaning challenges, and we are using them as a use case for us to show the value of data engineering, proper data engineering, when you can do it fast and robust. So it works with large data and with poor quality data. And we do want to get engaged. So specifically, in fact, it will take a community or a village, right, as they say. It takes a village to grow a child or to grow a baby. In our case, the baby would be our Canada, a solution for everyone. But we do need efforts from other departments in organizing the use cases, for example. You know, we call them challenges. So if you have a problem of cleaning, why not to just describe your problem, put it in our portal, and maybe we will just show you how you can do it, and then you can maybe multiply our efforts by your effort. Of course, there are many data sets, and we just don't have time to examine all those data sets. And of course, we do need to test and benchmark. Benchmark means really it's in a systematic manner. It's the way they do it in software engineering. It's like a stress test with large portions of data, because many packages are found work very nicely when you have 10, 100 records, maybe 1,000. But when you have 1 million records, they just freeze your computer. You cannot do it. So that's why benchmarking becomes important. So again, you would be very welcome to be part of this initiative. And now, time for entertainment, as I would say. But before we go there, again, I would like to show this picture which I found on LinkedIn, as if the cloud was listening my thoughts, you know, as I was preparing for this presentation. Someone just posted this beautiful picture, a data engineering who is saving the life of data scientists by keeping all this huge amount of data, which is going and going, and it just is going to crash the data scientists unless we build tools. Now here also you will see all those many packages which I have tried, tested, and I can tell you I have now my opinion. on all of those. Eventually, I think it would be nice to share our opinions, not only mine, but opinions of the community, and share our experiences. I also provided some reference for the papers. You would see that many of them date 2010. So how to detect errors or how to link the data. And of course, lots of data is available in open space. So time for the demo. So at this point, I will share a different screen. It's good time, by the way, to ask maybe one or two questions, and I will just change the screen. Sarah, so you can check if we have any questions.
Yeah, so there's actually a great question here on what are the advantages of R over Python, and what's the reason for developing your data engineering toolkit in R and not in Python?
Very, very good question. So let me share, as I answer this question, let me share the screen. I guess right now you just see myself probably, right? So because what I'd like to do, I'd like to open, if you open the Shiny app, I have created info tab there, like information, where I provided some information, especially to answer some questions like this one, which because I was expecting people would be really wondering, let's say, what are those different metrics? Because there are many acronyms, or why we're using R, or what Shiny is, for example. So, and that's why we put all this information into info app. So I will start sharing my screen right now. Sarah, just please let me know if it works well. Screen number 2. Now, do you see my?
I sure do.
Okay, good. That's very good. So that's how the app looks like. And to answer your question, actually, you would see that in the raison d'être, pourquoi on travaille sur ces problèmes-là, and why we're using R. So actually, I posted it in here. So according to IEEE Spectrum, R is ranked number 5, and it's the fastest growing. In fact, I mentioned that already in its popularity, and specifically because of some additional functionalities that were specifically developed for data science needs. Because Python, it's another language which is very, very good language. But it's a generic language. It's used for data engineering or for engineering, like electrical engineering, for robots, for example, for Raspberry Pi projects in high school. It was not built specifically for data science, but R is built specifically for data science. So here we actually even listed data functionalities. If you click here on additional functionalities in Info tab, it's in here, in iAdvantages.
Perfect.
So it's called R Advantages here. You would see many reasons why it is good. So first, it's fully compatible with Python. So you can code in Python and R, and you can change your code with each other. But very importantly, again, it uses it allows very fast in-memory processing of data. It's, by the way, very important. Imagine you have millions of records in your data set, and you want to change just one line. You cannot copy the entire huge data set into other memory of your computer. You should just never do this. You should do it the way it is done in R. You should, what is called in memory. You just replace this one single spot in your huge memory. You never copy the entire data set. That's a proper way of doing it. And R has a good way of doing it. And of course, I mentioned Shiny already. So this is the answer to this question. Okay, do we have other questions?
A number of questions. One that I'll point out is there's a question around, it says, I'm currently working with R and I use it a lot to integrate data from many sources. What is your view about system integration via a central repository versus using R to do this?
So if I understood the question, there are two ways of working with R. there is a community or a centralized repository. By the way, it's one of the advantages of ARP, by the way, very important here. Actually, I even would like to emphasize it here. Can you see it like I have highlighted this portion here?
Yeah.
So essentially, the packages which are developed, they're curated. It means that they're tested, they're peer-tested packages. So they are already trusted. So if I develop a package myself, in fact, you don't need to trust it. Even though I can tell you it's a very good package, actually, unless it is really tested by professionals and in a professional manner, it is risky. Just risky to use this package, especially when you do it for big projects which rely on the package. So there is this repository called CRAN, or CRAN, and the packages there are curated. So it's very, very powerful tool. And packages which I'm using here, they were in fact developed, many of them 10 years ago, but they have been improved almost every year. So the latest updates were just like October, November, 3 months ago. The packages for data linking. So that's how it is important, how useful it is to leverage this curated by global community repository of packages. So I hope this answers the question.
Perfect. So I'm just thinking, and keeping an eye on the time, maybe you want to do some of the demos now, and then other questions we can either answer at the end, or you can go back to the Slido after and address those, if that works, Dmitry.
Yeah, excellent. So when I was developing this app, so first, this app is developed entirely in R. It's all free. You can learn it yourself, and in fact, we even invite you to join us for lunch and learns R. If you click here on R Canada, you actually go a link to we do it regularly, just meet for fun, and you're welcome to join just discussion. And when I was developing this app, again, it has two objectives here. First, of course, we would like to show you the functionalities or the beauty, the power of art, and to tell you that you can do it all yourself. All this is free, all tutorials are available. So this is task number one, just to show you, to introduce you to all the spectrum of different varieties. And that's what we say here, that this app is structured in such a way that to provide you a gradual introduction to different data engineering challenges, from basic single variable cleaning tasks such as, just recognition of dates or postal codes, and eventually to more complex multivariable tasks where you have large data sets of name records, and then eventually full automated use cases, maybe like find automatically date of, for example, the birthday date of prime ministers. I use this example. Full automatically. Now you can do it. You could go here, and so I'm showing you. You can go to use cases, and you can type here the name of a prime minister. And by the way, you don't need even to worry about how many spaces here, how you write it, and it will find it. So you can paste in here, and it just goes to Wikipedia, and after some time, it will automatically extract the data. Now, this is the final sort of ultimate task. But what here I would like to show you is how to do the data linking using your own files. So what I suggest, we still have some time, so you are free to play with it. You can go to dates, and you can start typing the date anywhere you want. You can spell it different ways, and you can see how computer works. If you spell it this way, it will not recognize it. But if you spell it like this, it will. So, and you see right away, I change the input and how my output changes. So it's live. The system is entirely live, and this is what happens. You can really you can type the date any way you want. You see it like that, and you see it has extracted automatically those three numbers. So that's what data engineering is about. That's what automation is about. You don't need to worry anymore about how you spell your date. The numbers are automatically extracted. Similar with timestamp. There is a huge problem. My colleagues told me that they cannot get timestamps because sometimes they're spelled just like that, or even like that, and it is not converted to a date. Yes, the date should be converted just like that. So again, you can play with this. You can play with names. Now, this is a very good tab. Also, you can play here. It also outlines different metrics which I use here. Similarity metrics. If you don't know what they are, we have included in for theory, and in theory you can learn more about different metrics which are used in R. All those abbreviations. And this tab will allow you really to see what the distances are. For example, I use a public data set of common English names, and I type Justin, for example, and you would see the distances. So Justin, of course, will have a distance 0. It's the same, it's exact match, but you see the different metrics, like qgram will have a difference of 1. But as I say, sometimes they're converted to a number between 0 and 1. So, and this, what you would have a number. It's a distance. It's a distance between Justina and Justin. And you can write any name. You can write your name. I can write my name. My name is, by the way, not as among English common names. So if I put a threshold, 0.2, you see no names are extracted. So I need to increase the threshold. So you see, I increase threshold using this similarity Jacquard. Jacquard, it's a Q gram metric, but which is normalized, a number between 0 and 1. And you see that the closest one is, so they are sorted by this metric. So the closest name which was found closest to mine is Myrti. And by the way, Soundex showed that it's the same pronunciation. So Myrti, Dmitry, sounds à peu près la même chose, oui? So you can find a name just like that. You can find similar names. So this is already, it's a good example on how you can search without knowing how the word is spelled, using different similarities. And also here you see the challenge. Because sometimes one metric is good, sometimes the other metric. So you can use Soundex, and it will find spellings, different spellings of my name according to Soundex. So, but here I would like now to invite you to see how you can use this app using your own files. So, I have made a few spreadsheets. I hope you can see them right now. So in fact, actually, it's not me who made it. These are used in public domain tutorials. So credit to all the public domain. Again, I'm trying not to spend time even building my own examples when they are already made by my fellow colleagues elsewhere. But they show you the challenge. You have a name where Charlie is spelled sometimes Charles, sometimes Charlie. And this should be linked, of course, at the same person. You have a name, or you have a street, sometimes it's spelled like this. In Canada, we have sometimes Rue La Vérendrye or La Vérendrye Street. And sometimes, abbreviated different way. So these are different spellings. So what we would like to do now, you can do the same. You have your own spreadsheet. And I can tell you that it doesn't work with big files. When I was trying to do it with the 1,000 lines, it was not working. But with small files, it should work. It is fully functional end user tool. You can create your own file. You can use your file from your own work. And you can do two things here. I will show you what you can do. You can do did application and linked. In the application, essentially, you should see that this line, that line 4 and 5, they are the same, right? And when you link, it also should link according to some criteria. I will show you now how you can do it. So I'll close my spreadsheet. In here, you can upload your file here. So I open browser, I open it, it's in here. When it uploads, you can see exactly the same data right here, right? Now, when you click deduplicate, it actually shows you the final result. It shows that it has found 3 groups of people. Essentially, it linked the first 2 lines and the third and the fourth line. Okay, you see it's all live. See, I need to reload. And by the way, that's the beauty of it. You see, it's entirely live. This is the beauty of robust data engineering. This system will run forever with any data in the future, if it is developed correctly. Now, it's live, so that's we need to wait until it loads the data. But I can tell you, you can do the same. Now,
there's actually a question that may be good at this time, Dmitry.
Yeah.
So Tony from iSaid has asked, do you have the premium version of Shiny apps, or are you using the limited free version? And have you considered or explored a Shiny apps server, and what challenges have you had with that?
Okay, very good question. So free version is good enough. In fact, I have not had any problems using free version. So it's free. It's again, the codes, by the way, will be shared at again at GCConnect. So I think I will have to do it again. I will try to do it fast now. So again, let's try to do it again. I open my file. I open one file. Now I click deduplicate. It links. Now by default it uses identity, meaning exact match. And here I will say show entire table here. So you can see the result. Now I will show you the interim results. But this is what you need to know. Click here. It shows you the result of matching, because you need to compare each word to each word. So what you see here, you see 25 pairs. Because 5 to 5, right? 25. And you would see where they match or not matched. Of course, it's true when it is exactly the same. Now, if I use a different metric like QGram, you would see that now the metrics are not binary. They could be 0.6. And this is where you can start playing with the threshold, and you can say, okay, my decision threshold, I can change it, and you can see the final result will be different in this column. So you can put threshold higher, and then there will be less matches, right? So there will be more false results. So, and this is the final outcome here. You can see you can play with different metrics. Currently, here we have 3 metrics: largest common substring metric, QGram, and what is called Jara-Winkler, which is a heuristic metric which penalizes for errors in the beginning of the word. And all of these 3 metrics, they are normalized between 0 and 1. So this is why they're used here. Now I will show you how you can link. Go to link, then when you click here, a new window pops up here. You can say, now I want to upload another file here. And I will upload the second file, this one, slightly smaller file. Now you can toggle view between first file and second file in here. So second file, 4 lines. First file, 5 lines. Now the result is shown here. So again, in the beginning, let me show the result using identity. So using identity and a threshold of 2.7. What means 2.7? It means we need at least 2 matches. So you're comparing all fields. In fact, all fields are written right here. These are extracted automatically. You see 5 fields. We have 5 variables. And based on those 5 variables, if you need only 2 of them to match, you see that they're linked quite well. But of course, you can change threshold in here to be it larger, and it would change the results in here. So that's the key functionality here. You would be able to play it with your own data. Now you will see the results, interim results in here. Now also I would like to show you that you don't need even to use your own data, because we have preloaded a lot of data from all open sources. So for example, we have a collection of German names or American names, or in fact we added a code to get live COVID data. And this is entirely live data. It's written from our, by the way, our lunch and learns. We were doing it. So this is live data, and I will show you some functionality which you may find just useful in itself. This functionality is called search and save at data. You can click here on Ottawa. You can show all results. You can change the date, let's say the last date, and you can see the results, COVID results today, and then I will show you how you can save it. You can click here on CSV, and it will save you the result as a CSV file. As simple as that. So this is essential to say that many of data sets are already uploaded. This is live, by the way. So this is the situation we have with COVID today, actually. So I think this is probably a good time to conclude the presentation. Again, I invite everyone to play with the data which we have here. And again, you can reach me by email. And I hope to see you working together on this project. Maybe just one more thing, which I didn't mention, that to speed up the linking, when you want to link the data, you can do what is called, you can freeze one column. You can say that you require one file, one variable to be exact. So maybe at this point it's better to stop here because it's live. But you will see it here that you will be able to select columns. You can link only by 3 columns, for example, and then you can freeze some of those columns if you want. So there is a lot of functionality, and now it's time for questions.
Yeah, so there's one here that I'm hoping you can answer. Someone said the R for GC GitLab project looks empty to me. How do we gain access?
Now, you do need your account first. Secondly, R for GC, you should have access if you're logged in. It's not yet open to public. And this is something we could potentially discuss. At the moment, it is available to all registered users. So you have to be a registered GC code user to be able to see that.
Okay, sounds good. There's actually a similar question. Do you have any public-facing Shiny implementations? And this is from someone at TBS. They said, we've experimented with Shiny for internal use, and they've given their GitHub link there. They said, for example, but we've never deployed to public-facing websites. So I'm not sure, Dmitry, is that something you've ever discussed or explored?
Oh, okay. That's a very valid question. So first, as you would see, this Shiny app is hosted at shinyapps.io. This is a portal, it's a free portal, which is not ours. It's not even, it doesn't reside in Canada. It's probably somewhere in California, I don't know. It's just provided by R. And we use it for demonstration purposes. Again, as emphasized, we are not ever uploading our protected data or private data or any internal data. We use only open data, and it's only for the purpose of testing the technologies. We're using only open free data, we're using open free codes, and we're using this open free Shiny Apps IO portal to host. So I can tell you that at the moment at CBSA we do not have our internal Shiny app. Okay. This is something which we're discussing, because at some point, of course, we would like to test it with our own data. And I know I've been talking to my colleagues, it is possible to do it internally as well. So we can host it internally on our internal network, on a protected network, so that we can run it with our own CBSA data by the time, when we already have the application developed. Okay, so next question.
So I'm just going to go by questions that have the most votes now, and I guess what we don't get to, we can look at after the fact. So the next question here is, the biggest problem with Shiny is that IT departments are hesitant to run Shiny servers for various reasons. How do you go around this limitation, and have you worked with IT on this?
Again, I understand very well what people are talking about. Here, I would say we have a different approach here. We have divided our task in two portions. One is where we test the technologies, where we're trying to find the best possible tools for our job, because tools are available in public domain. And to test those tools, you do not need to use your own IT. You do need to test them anywhere. You can use it on your own home machine or on Shiny apps. So when you test third-party products, it doesn't matter where you test them. So we have made a clear distinction between testing third-party products and then developing our own codes. So when we develop our own codes for many of our projects, like we have removals, dynamic reskin, and many evaluations, and many like COVID projects, all this is on a separate network, and we do not bring these codes there. We will bring it only after they have been tested, selected, and then we will find a way to maybe just create a package, our own package, which will be just for CBSA and which will reside only in CBSA. So again, it has to be understood that in order to advance our knowledge in R, it is important that we do not close ourselves within our own walls. Yes, we do need to be very careful on how we handle data. We do have to protect our data. We do not need to be careful or not to allow in third-party products into our internal network. But at the same time, we do need to find tools which are developed in 2020, not in 2005 or 2010. As mentioned, R has developed in the last 5 years, probably like electricity has developed 100 years ago. In fact, it's a good, parallel. Data science is electricity of 21st century. We need to know, we need to become literate, like we're literate with electricity. We need to become literate with data. But data is all over the place, and you need to know how to handle it, how to be able to manipulate it, all those techniques, all those different references, tools. Because then, once you learn them, you can bring them into your own internal network.
Okay. So I'm going to close us off with this question and give you a chance to plug where people can find you. So someone said, I run a community practice group for R in my department, but we have very little resources and few members. How can I get more help for our members to enhance their knowledge and spread the word about R?
Welcome to our Life and Learn. But in fact, actually, you know what? I found we live in such a special time that we sit separately all over the country, right? And we do need socializing with each other just to socialize. So I found it's good for myself and for many of my colleagues just seeing each other's faces. So that's why we just have this every Friday from 11:30 to 12:30. We have time where we just go to MS Teams, and I have questions. For example, I was asking them ideas for this presentation. I was asking for translation into French, and pour moi c'est aussi bon moment pour pratiquer mon français, par exemple, des choses comme ça. Et R aussi pour pratiquer R aussi. So, but what I found the best way is that we come up with an idea. Like, for example, we have idea to last summer it was idea, why not to build app to visualize COVID with R, with Shiny. Wonderful. So let's just dedicate our next 10 meetings, our meetup meetings. We will be developing codes, and we build these codes. And these codes are right now available. You can see it from that link in here. You will be able to see it, the code which we built to visualize code. Now idea is maybe we can visualize PSAS results. It doesn't matter what it has to do, but it's free, and we're using the codes which are already developed. It's only what I found. What is very important is just to provide examples, like hands-on examples, and I think that's the best way to learn. And again, myself, I started programming myself R in 2014. Before that, I was coding only in C++. And at NRC and at CBSA as well, doing all our lots of data processing there and video recognition technologies developing there. So you can learn R yourself, and I think if we do it as a community, it helps all of us. Yeah.
Perfect. So again, the presentation and the links that Dmitry had in his presentation are available on the GCcollab page. So you can find Dmitry's contact info there and check out all of the links that he shared with you today. Thank you, Dmitry.
Yes, and just for the end, I just opened the screen of our OGC page. So this is what you would see, and in fact, as you would see, it is right now it's internal, but I will discuss with my directors. And by the way, I need to say a word of appreciation for the work of our directors and Kaveh, Afshar and Sandy Kyriakatos, because they're propelling this data science as a field, and allowing us to grow in our knowledge in our community. So I will be checking with them on how we're going to move on. But I think I've heard that they are welcoming it very much, working together. So indeed, I see that these directors right now are protected. So you do not see them, but once I get the permission from my directors, we will make them available to all Government of Canada, at least registered users of GC code. So I guess this should be an optimistic note to end this presentation.
Thank you.
Do you have any more questions, Sarah? What do we have? I see it's 10:15 right now, or maybe 14. Should I say a joke or sing a song? What people want us to do? Do they want to have entertainment here?
I don't know if you want to take a look at the last questions. We'll probably be closing off soon.
So maybe I'll stop sharing my screen.
Perfect.
So I can see questions. Okay. Okay. Oh, and maybe I know there are also questions at Shiny, right? So let me open. Sorry, not the Shiny, Slido. See, I've been talking so much about Shiny that Slido. Let me check the questions at Slido. Okay. Oh, okay. So one of the questions. Okay, what should you do?